So GCMS spec on that diluted sample has now run, and we've got a rather different looking trace. We've got this big peak here between 1 and 2. Conceivable that's solvent, and then we've got a single peak here between 7 and 8 now. So we're going to go to post run and change things so we can actually see all those peaks. So the first thing I want to do is I want to go to the data comparison, and I want to put the Diels Alder product round 2 and the Diels Alder product round 3 on the same file. So you'll notice that I have these two peaks the same, but this peak here that was in Diels Alder product round 2 is not in Diels Alder product round 3. You also may have noticed that it seemed to have the same 253 molecular weight as this peak here. So what this is almost certainly due to is the product from the first round that didn't come off under those conditions because we didn't get it hot enough and leave it hot enough for long enough, coming off in the next run. And that happens sometimes if you don't have the high enough temperature. So I think that and that are the same compound. And if we close the data comparison, if we look at the round 2, this came from the round 1, and this one actually came from round 2. This other peak here is probably solvent as a result of not having a long enough solvent cut time. I probably should have had a 2-minute solvent cut time. So what we'll do is we won't integrate it. If we look at that peak, the detector is saturated. It's low molecular weight material. It's probably solvent. Methanol, or something like that, or maybe even a stabilizer in the product. But this is the product we're after. This is the product of interest. So when we integrate, we're going to integrate only that peak by turning the integrator on at 7 minutes. All right, we're going to leave the integrator off at time 0, turn it on at 7 minutes, and off again at 9. Well, 9 is the end of the run, so we don't really need that command. But we're not going to integrate anything that happens before 7 minutes. It's not picking that peak up, so I'm also going to change this minimum area to 100,000, just in case that peak was too small. Right? And you'll see that because I diluted it, that peak was too small to be picked up. So now we have a single peak being picked up with a molecular weight of 253. Hopefully that's the molecular weight of the product. And then some distinctive fragments. And none of these are red, which means that the detector was not saturated. It's not off scale for this peak. That is something that should have been part of the solvent cut. So we can save this data file. And then we can go to the report forms. And I don't have a report format file that's specifically made for this compound. So we'll open a format file. Actually, we'll just open the Morpholine Solids format file that was there. And we'll drag our product in. And it turns out it's not a terrible file. We have this going from 5 to 10 minutes. We really only need to look maybe from 6 to 9. So by right-clicking on this and going to chromatogram object properties, we can change that setting from 5 to 10 so that we're looking just from 6 to 9. And you'll notice this peak's really small because it's normalizing to the first highest peak. So I also want to change that so that instead of normalizing to that highest peak, it's normalizing to the second highest peak. And that means I need to find that setting. And maybe I need to turn off the normalizing. There we go. So it's not normalizing now to that high peak. So we see a nice sharp peak here. Base peak of 253. That's kind of nice. The molecular ion is not usually also the base peak, but it looks like in this case it is. So we've got a nice table. Probably more peaks than we really need. in that table. It's showing a whole bunch of things here. So we can also try to mess with those properties and see if maybe we can make that a little less sensitive. Except that I don't remember how to do that. So it's going to print a lot of peaks, I think. Maybe not. Yeah, because this is still an EM over Z175, so it's not picking up these others. Those are off scale here over on the right. Well, let's see what it does. We'll just print it. And this is Diels Alder product. Save that. And it's looking pretty good. And I don't need to save that report form. So that was successful. We had to mess with the method just a little bit, and I'm going to change this method now to make the solvent cut time 2 minutes and the start time 2.1, so that when we run this in the future, it works. Save that method file. So there we go. And close that.